if I go for question number 16, a cycle tire of mass m and radius r is pure rolling over a horizontal surface. If pure rolling is there, then the linear velocity of center of mass will be equal to r omega. And if I consider this is equal to v. So if the velocity of center of mass is v, then the velocity of point P on the tire shown in the figure. And we know that the velocity of center of mass, I mean to say linear velocity, the direction of linear velocity at any point will not change. But as per the situation, if I take this point is P, so this is the r omega and this is the direction of linear velocity. So we'll see angle between these two is 90, right? But as per the situation, if I take another point P will be here. So there is no confusion. Angle between these two, suppose this is my point A, this is P and this is P dash, okay? But this angle is 60 as per the question. But the total angle between point A and P is 90. So we can observe that the next point P will get after moving angle 30 degree. But at point P the angle between linear velocity or velocity of center of mass and r omega is 90. But when I will take this point P, because 30 angle will rotate, so we can say the angle between the velocity of center of mass and r omega will be 90 plus 30, so that is 120. So now I am going to take the velocity. So we will use v is equal to, because I need to calculate velocity of point P on the tire, so that is v square plus r omega square plus 2 times of b r omega and cos 120. But as I said, r omega is equal to b. So when you will solve v square plus 2v square and the value of cos 120, cos 90 plus 30, so that will give you minus sin 30, so that is minus 1 by 2. 2 will cancel and minus v square plus v square will cancel out. So I have only v. So this is the velocity of point P on the tire shown in the figure. So on behalf of that we can say my option number 4 is correct. Let's move on question number 17. In the question number 17, a thin rod has a mass m, total length is 2L because x0 will be here. So this length is 2L. I1, I2, I3, I4 are the moment of inertia of the thin rod. The axis 1, 2, 3 and 4 respectively. Which of the following relation is correct? So if I make the diagram once again, as per the question, this is x is equal to minus L and here x is equal to minus L by 2 and this is x is equal to 0, means origin is there, and the next point is x is equal to plus L by 4 and finally x is equal to plus L. According to the problem, I1 is there and axis number 2 is there, axis number 1, axis number 2 and this is axis number 3 and this is axis number 4. मुझे I1, I2, I3 में relation चाहिए. तो if I go for parallel axis theorem, so that is ICM plus MD square. So first I will concentrate I2. So we'll write ICM plus MR2 square because I am going to take axis number 2. But axis number 2 will pass the origin. So we can observe R2 will be 0. So we have moment of inertia acting moment of inertia about an axis number 2 will be at least, because that is equal to ICM. ये सबसे कम होगा, यानी कहने का मतलब ये है जैसे जैसे R2 का डिस्टेंस इंक्रीज करेगा मोमेंट ऑफ इनर्शिया विल इंक्रीज, बट सबसे कम होगा I2 पर. तो अगर हम यहां से देखते हैं, इफ R इज मोर, R दिस R और D, यू कैन ऑब्जर्व जैसे जैसे आपके D का वैल्यू इंक्रीज करेगा या R की वैल्यू इंक्रीज करेगी, R इज द परपेंडिकुलर डिस्टेंस और D इज द परपेंडिकुलर डिस्टेंस, वैसे वैसे मोमेंट ऑफ इनर्शिया आईसीएम में ऐड होता चला जाएगा. तो अगर हम लोग देखें, सबसे ज्यादा सेपरेशन एक्सिस नंबर 4 पर आपको मिलेगा. सो वी कैन से I4 इज हाईएस्ट, एंड इफ आई गो फॉर एक्सिस नंबर 3, then value of D or R is L by 4. But if I go axis number 1, then value of D or R is minus L by 2. But we will take in terms of square, so there is no matter minus L by 2 or plus L by 2. So we can say the second number is I1 and third is I3 and minimum होगा I2 पर. तो फाइनल कंक्लूजन ये है कि जैसे जैसे R और D का वैल्यू इंक्रीज करेगा, उस एक्सिस के अबाउट मोमेंट ऑफ इनर्शिया सबसे ज्यादा होगा और I2 पर सबसे कम होगा, बिकॉज R इज इक्वल टू 0. सो बाय दिस डिस्कशन, दिस इज माय फाइनल रिलेशन. I4 is greater than I1 and I1 is greater than I3, I3 is greater than I2. So we can say my option number 4 is correct. Let's move on question number 18. So I am going to take the question number 18. A boy of mass 30 kg is standing at one end on a stationary boat over a lake. The boat has a mass of 70 kg and length 10 meter. Now the boy walked to the other end of the boat relative to the ground. This is relative to the ground. So if I consider one suffix for boy, so we can write M1 is 30 kg and 2 for boat. N2 will be 70 kg as per the question, because I am going to take X1 for boy and X2 for boat. Okay. So if I go for the position of center of mass X1, so we'll write M1 X1 plus N2 X2 divide by M1 plus N2. So I am going to place the value 30 into, because I am going to calculate the position of center of mass by taking the origin of the boy. So X1 will be 0 and minus 70 into 10, because the boat has a mass 70. Now the boy walked to the other end of the boat relative to the ground. 70 into 10 and 30 plus 70. So on solving, we'll get minus 7 meter. In terms of magnitude, we'll write 7 meter only. And now, second time I am going to take the position of center of mass by taking origin of the बोट के रिस्पेक्ट में हम लोग सॉल्व करते हैं. तो x2 विल बी m1 x1 प्लस n2 x2 डिवाइड बाई m1 प्लस n2. सो इन दिस टाइम m1 इज 30, x1 इज 10, बिकॉज अब आपका ओरिजिन चेंज हुआ है, एंड 70 इंटू 0 डिवाइड बाई 30 plus 70, so we'll get 3 meter. अब हम लोग अपने ऑप्शंस की बात करते हैं. Boy has moved by distance 40/7, no. Boy has moved by 30/7. Boat has moved by distance 7 meter, no. Boat has moved by distance 3 meter, yes. This is correct. So we can say my option number. So let's move on question number 19. So So now I am going to take the question number 19. A uniform plank is supported by two equal forces, 120 Newton at X and Y as shown in figure. If the support at X is moved to Z, then supporting forces at Y and Z are. If I take initial condition, so initially force at X is 120 Newton and force at Y is also 120 Newton, but we are seeing that there is no rotational motion. So if I take the torque about center of mass, so mg will act at the center of mass, and initially if I take torque, so torque, first torque due to Fx, so Fx, and we need perpendicular distance, that is L by 2, so this is L by 2, and this torque having the sense of direction in clockwise direction. And if I go for the torque created by Fy, so we'll write with the negative sign because the direction of this torque is anti-clockwise and perpendicular distance is L by 2. This is initial torque, but as I said, as per the question, the magnitude of force will be equal, so we can cancel them. So initial torque will be 0. So in this situation we can write Fx plus Fy managed by the weight, or if I say the net force along y-axis, so Fx, Fy along positive y-axis, and mg will act in negative y-axis. So if I will use sigma F equal ma, and you know there is no acceleration, so acceleration will be 0, sigma F along y will be 0, so we can write this. And you know Fx and Fy having same magnitude, that is 120. So when I will place the value, we'll get mg is equal to 120 for Fx, 120 for Fy, so we have 240. The value of mg or Fx plus Fy is equal to 240. Now I am going to take the torque in second situation, when support X is moved to Z. So when support is moved to Z, and if I go for the torque with respect to the center of mass, so torque due to Z, perpendicular distance in this time will be L by 4, because this is L by 4 is given, and that will be equal to torque created by the Y, and perpendicular distance will remain same. But why? Because there will be no change in Fy, right? So now Fz and Fy, L 2 to the 4, L will cancel out, so I have a relation Fz is equal to 2 times of Fy. But I need to calculate the value of Fz and Fy. So by the diagram, by the second situation, the two forces Fz and Fy will be equal to the mg in this situation, because there is no linear motion. So we'll write Fz plus Fy, that is equal mg, and mg is equal to 240. But we know Fz is equal to 2Fy, so we'll write 2Fy plus Fy, that is equal to 40. So value of Fy is 80 Newton. But if I want to calculate Fz, so when I will place the value of Fy, that is 80, so that will give you 160 Newton. So I have two values, Fy is 80 Newton, Fz is 160 Newton. So there is no confusion. My option number 4, Fy 80, Fz is 160, so option number 4 will be correct. So let's move on question number 20. Now I am going to take the question number 20. A thin uniform wire of mass m and length L is bent into shape of semicircle. This is. semicircle, the moment of inertia of that wire about an axis passing through its free end is. So this question is from our study package. So this is the situation. I need to calculate moment of inertia of this. So we, with respect to the diameter, because these 2 points, when you will connect them, will get moment of inertia about diameter, and that is, in the case of ring, is mr square. Formula will not be changed. But there is a problem. I had no idea about radius, but as per the situation, length is equal to pi r, because the length of wire is L and it will be bent in the form of semicircle. So L is equal to pi r and r is equal to L upon pi. So when I will place the value 1 by 2 into m, and in place of radius L upon pi with the square. So on solving, we'll get ml square upon 2 pi square. So this is the final value. So on behalf of that, we can say my option number 2 is correct. So let's move on, question number 21.